Now that we know several identities, let's use those identities to find function values that we do not know. In example 4, we are asked to find sine theta, given that cosine theta is equal to 4 over 5, and we know that theta is in quadrant 4. So we are asked to find sine theta, and we know that we are in quadrant 4. What is the sign of sine theta if we are in quadrant 4? Well, sine is negative in quadrant 4. So I will go ahead and put my negative sign there so I do not forget to remember that sine is negative in quadrant 4. Now, how do I get from sine to cosine? Using identities. So we're asked to use identities to do this. Well, our Pythagorean identity will help us here. Sine plus cosine. So sine squared theta plus cosine squared theta is equal to 1. So this is our Pythagorean identity that relates sine values to cosine values. So we will use this identity to determine what sine is from cosine. So we don't know what sine is, so we'll see that as sine squared theta plus cosine we know is 4 over 5. So 4 divided by 5, and we need to square that. And now we have an equation that we can solve for sine. So sine squared theta plus, and we will square 4 over 5, that would be 16 over 25 is equal to 1. Now we can subtract 16 over 25 from both sides of our equation. And we know that when we subtract, we do need to have a common denominator. If I was to write 1 with a denominator of 25, of course that would be 25 over 25. So now we have that sine squared theta is equal to 25 minus 16 would be 9. Keep our same denominator. And the last thing that we want to do is to take the square root of both sides. Now remember that when you take the square root of both sides of an equation, we always want to include our plus and our minus. So the square root of sine squared would be sine. Sine is either equal to plus or minus, and the square root of 9 would be 3, and the square root of 25 would be 5. So it's either plus or minus 3 over 5, and we said that we are working in quadrant 4, so we know that it will be negative 3 over 5. In example 5, we are asked to find tangent theta given that sine theta is equal to a positive 1/2 and theta is in quadrant 2. So you want to find tangent theta, and we are told that theta, our angle, is in quadrant 2. If our angle is in quadrant 2, we know that sine is positive in quadrant 2, but tangent will be negative in quadrant 2. So let's go ahead and put our negative sign as part of our answer so we don't forget that part. Now, in order for us to get from tangent to sine, we will use our quotient identity. Tangent theta is equal to sine theta divided by cosine theta. Now we know that sine theta is positive 1/2, but we do not know what cosine theta is. So we cannot directly solve for tangent theta with our quotient identity. We will have to figure out what cosine theta is first. Once we know what cosine theta is, then we can simplify this expression. In order for us to get cosine theta, we know sine. What identity relates sine and cosine? Well, that will have to be our Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Sine squared theta, well, we know that sine is 1/2. we'll square that, plus cosine squared theta is equal to 1. 1/2 squared would be 1 squared, and then 2 squared would be 4. We will have to solve for cosine squared theta, so we will subtract 1/4 from both sides. Now I know that cosine squared theta is equal to 4 over 4 would be the way that we would rewrite 1, so that we have a common denominator with negative 1/4, and that gives us a positive 3/4, and then take the square root of both sides. That leaves us with cosine theta is equal to plus or minus, and we're going to simplify this, the square root of the top divided by the square root of the bottom. The square root of 4 would be 2. Now we are working in quadrant 2, and in quadrant 2, cosine is negative. So now we know that tangent theta is equal to 1/2 divided by our cosine value, which is negative, square root of 3 over 2. We want to simplify our expression. We have 1/2 times, we will flip the bottom fraction, so that would be a negative 2 divided by square root of 3. Cancel out our common factors of 2. So now we have negative 1 divided by the square root of 3. So our tangent value is negative 1 divided by the square root of 3. Before we say this is our final answer, we want to get rid of that square root that's in our denominator. So we will multiply the top and the bottom by the square root of 3. So our final answer will be tangent theta is equal to negative square root of 3 all over 3. And that is what we knew, that tangent theta would be negative, and so this is a reasonable solution. So tangent theta is equal to negative square root of 3 over 3.